Hello everyone. In this video we are going to solve the following problem. Given that limit of the function f of x is L, which of the following statements, if any, must be true? So you can see that the word must is emphasized, therefore we need to be careful how to answer. So let us start with A. It says f is defined at A, based on the fact that limit when x approaches A, f of x is L. Well, this is not true, and there are many ways to tackle this problem. So first way, using definition of the limit. When we have the definition of the limit, you can recall that it means that the function is defined in a neighborhood of the point A. So this is A, except maybe at A. So f can be defined on some interval containing A, except maybe at A. So f doesn't need to be defined at A if limit when x approaches A, f of x is finite. That means exists as a real number. So this is from the definition of the limit. Therefore, we do not demand that f is defined at A. That means f being defined as at A can be false. That is, doesn't need to be true. This is E. Second way is actually to find a suitable function which is more appropriate, and then show that the finite limit can exist, but the function is simply not defined at A. For example, it's a very artificial example, but it works. So any example that works. So you have, for example, function. Let's say this is, let this be 3 here, and this is f of x equals x minus 3 squared. Now we will just use one trick here. We will just erase here 1 point, so we can put here like an empty circle for, let's say this is 3.7. What you can see from here is that obviously limit when x approaches 3.7 f of x, it does exist from both sides. That is this value here, which is 0.7 squared. Is 0.7 squared. But the function is not defined there. But f is not defined at 3.7. And that's also the way to answer. So one way is to go back to the definition, which explicitly says that there must be a neighborhood where the function is defined, except possibly at the value for which the limit is asked, and so on. So doesn't need to be true. B. F of A equals L. Again, it doesn't need to be true, because you can say using A, part A, f of A doesn't need to be defined at all. And you can again use this function here. Okay, so f of A equals L need not to be true. Okay, so here f of A equals else L need not to be true. Okay, so B is answered. C, F is continuous at A. Again, no. Again, you can use this way here. So second way solving. So again, not necessarily. And you can again use this function here, and everything what we said here, it doesn't need to be continuous at A because it doesn't need to be defined at A. You can just add it might not be defined at A. You can go further, be more creative, and use again the same function for any modification. So you can say, okay, let me do here one thing. Okay, this is my f of x. Then I will just again delete one point here. Okay, I will make like a circle, and then I will put here the dotted line, meaning that let's this be 3.5. So obviously limit when x approaches 3.5 of f of x is a real number. Why? Because limit from left and limit from right. But this is different from f of 3.5. So even it can be defined, but it doesn't need to be the same as the value of the function. Let this maybe be 5, let's say, which is 5. And let this be 2. So if this is 2, in order to be continuous, those two numbers have to be the same. So the value of the function must be the limit in order to be continuous. And f is differentiable at A. Well, this is super easy. We know that not continuous implies not differentiable. So again, if you use any of these two functions that we mentioned, or anything what you like to construct based on this to get the idea, since it doesn't need to be continuous, it doesn't need to be differentiable. So again, not always true. And you can use any of these. So again, here also not always true. Let's just, so not always true. You can think of your own examples in these cases. Have a look again. Try to come up with your ideas. But this is the one of the ways to solve this. Thank you.